Good afternoon, everyone, and welcome to the UTS AI Showcase Workshops and Masterclass series. Thank you very much for joining us today for the Workshop 2. We will do a quick introduction and then get started with the second workshop. Before we start the workshop, I would like to acknowledge the Gadigal people of the Eora Nation upon whose ancestral lands our city campus now stands. I would also like to pay respect to the elders, both past and present, acknowledging them as the traditional custodians of knowledge for this land. Welcome again to the Workshop 2 on Build Your Own AWS DeepRacer Reinforcement Learning Model. Thank you very much, Juan, Andrew, and Jenny from Amazon Web Services Australia for all your help and support and kindly agreeing to deliver this wonderful workshop. I would also like to thank Natasha from Amazon Web Services Australia for all the help and support. She was to deliver this workshop, but due to ill health, she is not able to join us for this session today. I'd also like to thank the organizing committee members and the student volunteers for all their help and support in making this event a success. As you all are aware that due to the current COVID-19 situation, we have postponed the AI Project Showcase session, which was an on-campus in-person event scheduled today from 4 to 7 p.m. The new date for the AI Project Showcase in-person event will be announced soon once the COVID-19 restrictions are relaxed. So please keep an eye on the UTS AI Showcase website for further updates. If you have registered for the showcase, you will also receive updates from Humanitics very soon. So without further delays, I would request the AWS team to take over the session, and we all are looking forward to the wonderful workshop on Build Your Own AWS DeepRacer Reinforcement Learning Model. Thank you very much, and over to you, Juan.
Thanks a lot, Naveen. First of all, on behalf of the AWS team, we wanted to thank you for this opportunity to be discussing reinforcement learning on DeepRacer for UTS. So we're thrilled and honored of being part of this. With me, we have Andrew Kwok. Maybe just a quick introduction, Andrew.
Hi everyone, very nice to meet you. For some of you, I might have seen you before. I've been into UTS teaching about a bit about cloud in terms of storage, as well as I've helped a lot of different sorts of educational institutions understand a bit more about cloud. And that's my background overall as a solutions architect here at AWS for the past 2 years. And today, what I'll be teaching you is more of the hands-on practical component. Back to you, Kwon.
Thank you, Andrew. We also have with us, I think we are very lucky to have Jenny with us. Jenny is a very experienced machine learning SME within AWS. Maybe just over to you, Jenny, for a quick introduction.
Thanks, Mike Carlos. Thanks for having us, Nabin, and everyone on this call. Yeah, I've been working with DeepRacer for a few years now. Helped out at our reInvent conference in Las Vegas a few times, and have actually did the presentation for our AWS Summit earlier this year. So I've got quite a deep knowledge of the product, and I'm just here to support the team today if required. Thanks very much. Over to you, Juan Carlos.
Thank you, Jenny. We also have Melvin, who will be mostly as an observer and also supporting us. Melvin, if you want to maybe make a quick intro.
Hi everyone, Melvin Bice. I'm a solutions architect, primarily working in health sector. I'm learning about AWS DeepRacer, and very happy to join you.
Thank you. So let's make a start. So the objective of today really is to give you enough information, enough information about what you need to do in order to create a model, train a model, and participate in a virtual race. So that's our objective for today. The first part, I'll deliver a little bit of the theoretical content, and then Andrew will guide you on how to actually create the model and how to participate in the virtual race with a demonstration. The agenda then follows with machine learning on AWS first. We will have an introduction to the DeepRacer, the actual car. We will explore a little bit about reinforcement learning. Of course, it is just an introduction. We discuss about the console and what is behind the scenes. And we just discuss a couple of points about the DeepRacer League. Please, if you have any questions, don't hesitate to just, if you feel, just unmute your microphone, or if you want to make the questions over the chat, that's also welcome. The more interactive this is, the more fun it'll be for everyone. I'll anyway make some stops to ask for any specific questions. So, machine learning on AWS. So we have the Amazon Machine Learning Stack. It is a 3-tier stack where you can go from very high abstraction level at the top layer, and then get deeper and deeper into more specifics about machine learning science as you move down the stack. So at the bottom, we have the stack that is more suitable for expert machine learning practitioners. So that includes frameworks such as MXNet, PyTorch, or TensorFlow. You can use libraries such as Keras, Gluon, and you sort of go and create your model using code. So you really need to know exactly what you are doing. You will have the knowledge to identify when to use GPUs, CPUs, and fine-tune your model. Sorry. The mid layer is oriented towards developers. So our expectation is that developers without in-depth knowledge of machine learning are capable of building, training, and deploying models without having to get into the nitty and gritty of each model. That's why we offer built-in algorithms. For that, it also gives you the option to bring your own algorithm. But the idea behind SageMaker is to facilitate learning and creation of machine learning solutions for developers. The next layer of abstraction is where we offer off-the-shelf machine learning services. They are most of the time requested via APIs, and we have different options there. So if you need something like, for example, recognizing objects from an image, we have Amazon Recognition. If what you are after is move text to speech, then we have Amazon Poly. If you're into translating from one language into another, we have Amazon Translate. Some of you may be familiar with Amazon Alexa. So for chatbots, what is behind the scenes is Amazon Lex. And if you have things such as time series where you want to make forecast, we offer Amazon Forecast, and we also have Amazon Fraud Detector. So as I said before, you don't need really to know anything in regards to machine learning at this layer. So what you mostly use is an API call where you send an input and you get the output. I'll just make a quick stop there to see if there are any questions. Okay, I'll move on. We also offer some devices for learning machine learning. So for deep learning, we have AWS DeepLens. If you are into sort of generative AI, we use AWS Deep Composer. So Deep Composer takes text, video, and audio and try to generate media that sort of makes sense. And today we're focusing really on AWS DeepRacer, which is the card that you see on the right. And the idea behind it is to make reinforcement learning fun and easy to start. So let's have a quick look at DeepRacer. In 2018, SageMaker incorporated the functionality for reinforcement learning. And that's what enabled us to identify ways to make something that was easy for developers to learn about reinforcement learning. So that's how we came to this car, where we put actually, or literally, the reinforcement learning on the hands of all developers, or any developer who wants to learn the technology. So let's just start to talk a little bit about the car. The car is a 4-wheel drive 1 to 18 scale car. It has 2 cameras. So this new version is the version called Evo. It has 2 cameras, which is assists with distance measurement. And it also has a LiDAR sensor. So if you can see from the screen, there is like a black sort of rounded device at the top. That is the LiDAR sensor, and it's give you information about objects that may be around the car or in front of the car or behind the car. It has a 4G B RAM on it, and it runs OpenVINO. OpenVINO is a technology created by Intel, and it is visual inference network optimization technology. So you may want to learn a little bit more about that, but today we don't have time to get in depth with it. Okay, so I'll just make a quick stop here as well to just check if there are any questions or if there are any issues so far.
No questions at this point.
Okay, thank you.
Juan Carlos, if anyone's got any questions, they can pop them in the chat. I'm happy to answer questions as we go. We've already had one.
Okay, great. Jenny, do you want to maybe, is everyone able to see those questions as well to share the answer?
Yeah, everyone can see those. The only question so far is what prerequisite knowledge is necessary to do this workshop? Do you want to take that, or Juan Carlos?
Oh yeah, sure. Really, it's not much prerequisite really. So you probably be good if you have some level of Python, although the functions that we are going to work with are very simple. So I will probably assume that most people grasp them even with very little knowledge of Python. I don't know, Jenny, if you have anything else to add in regards to it.
No, I don't. We've got another question. This person is curious about the LiDAR position. From the image, it looks like the front of the LiDAR is covered. The answer to that is, you might want to cover here, Juan Carlos, the fact which way is forward on that car, and also just that LiDAR can see through the top because it's literally just an empty plastic shell sitting above those cameras. Okay,
thank you, Jenny. Yeah, so sometimes it is confusing, but if you look at the car that you have there on that image, you can see that you probably see 2 cameras, right? That's the front of the car. So sometimes it's a bit confusing and you may think that it is the back, but no. So where the cameras are is the front of the car. So, and as Jenny said, so it has still managed to get information that's sort of like a very basic shell to protect the car. So it managed to get that information on that LiDAR sensor. Okay, if no more questions, I will continue. Perfect. So we have, then, so what do you have in your environment? So you have, of course, the car, we just discussed before, and you're also going to have a 3D racing simulator environment. This environment is going to help you to train your model, and this 3D simulator is also going to be the environment you're going to use for competition. It's probably good to highlight that there are 2 steps to this. So the first thing will be for you to create your model. And during that creation and the training, that's one stage. Once your training is complete, then you get your model and you upload that model into your physical car or your virtual car. Today, of course, because of all the issues with COVID, we don't have the option to do it physically, but we will have the option to do it virtually. So the environment is going to be provided by this 3D racing simulator. We have the official AWS DeepRacer League, which has a championship during reInvent 2021. And there are 2 leagues there, Open and Pro. We're going to talk a little bit more about that. But we also have what we call community leagues, which give you the option to compete with friends or colleagues, or for example, this group. That's what we have used for this competition. Okay, so reinforcement learning for the Sunday driver. Just before making a start here, I just wanted to check if there are any other questions.
There's questions about can students try this without having to put a credit card and pay for an AWS account? And I was highlighting that there is the option for AWS to provide very short-lived accounts, and I believe Andrew is going to talk about that a bit later. Another question was where can we buy such a car? You can actually buy them on Amazon.com. I'm not sure if you can buy them on the .com.au site yet. I'll have a look and provide a link. But just to let you know, AWS does have a lot of cars. So if you're running an event, we can bring cars along for you to have fun with.
Thank you, Jane. So let's keep going. So artificial intelligence is this broad category where we sort of identify everything where we want to emulate human intelligence, right? Within artificial intelligence, we have machine learning, which is specific about how algorithms learn. And still within machine learning, this is quite a broad category. So we have multiple techniques. We have supervised learning, where you use label data to for the algorithm to learn, to sort of teach the algorithm based on previous label data. You have unsupervised learning, where you still provide the data to the algorithm without any labels. You sort of let the algorithm learn or identify information from a data set. For example, is used for customer segmentation or also for anomaly detection. And then we have reinforcement learning, where rather than specifically providing the data, what you have is an environment for an agent to learn. And what you use is incentives to reward the behavior you want the agent to exhibit. So this is really the focus of today, reinforcement learning. So we're not going to talk about any of the other techniques. We have a human way to relate to this, right? So this cute dog that you see in there is my son's dog. His name is Mocha. And my son was in this process of trying to teach Mocha to give him his hand. So at the beginning, you can see the dog very puzzled. So he doesn't know really what actions will trigger a reward. When the dog generates an action, so my son provides a treat, which is that image in the middle. And then after several iterations, then you get the dog to do what you want it to do. So finally, Mocha is giving my son his hat most of the time. So I'm pretty sure that most of us can relate to it, even at a human level. And actually, that was the inspiration behind reinforcement learning. We will need some terms in order to start to digging a little bit more about reinforcement learning and how to create our model within the DeepRacer environment. We have the agent. The agent is the entity that takes actions within an environment. So in our case, the agent is the DeepRacer car. We also have the environment. In our case, the environment is the track. You will see later on that we have several tracks to choose from. There is one specific for the competition, and Andrew will provide you more information about that specific track. We have the state. In our case, the state is provided by the images at a particular point in time. It's very important to be aware that states are related to time. So at a particular point in time, you'll have an image that defines what the state. You'll have, of course, other variables such as what is your direction, and you will have probably information about speed. You'll have actions as well. So you can define a set of actions. In particular, the actions that you have available to for the car to react to the environment are steering. So you could tell the car, you have this range, for example, for you to move between these particular degrees, and speed. And you can also set what speeds you want the car to go from. Of course, once you have these two variables, there is a significant space of actions if you combine steering and speed. You have the reward, which is the reward function. And this is what we want to, the way we want to incentivize the behavior that we are after. And we have an episode. An episode is where we count the cumulative reward for that episode. So what is an episode? An episode is the sequence of events that happens from the starting line of the car until it stops, either because it went off track or because it arrived to the finish line. I'll just make a quick stop there just to check for any questions.
None at this point.
Cool. So we have the reward function. This is the most important thing for you to be aware of in order to create a new model. And it is how you're going to tell the car what actions you want the car to exhibit. And it is at the core of reinforcement learning. Let's get a little bit more into it. Let's have a look at this very simple scenario. We have a straight line, a starting point there with that green square. And what we want to do is to incentivize the car to go on that straight line directly to the finish line. The bottom square, so assume that they are sort of off track, and the same for the top squares. Just assume that they are the off track lines. Just think for a moment, if you were going to incentivize this car to go straight over the orange line, what values do you think you maybe end up using? Just think about it for a couple of seconds. Okay. You probably came down to something similar to this, right? So what are we doing here? We're saying we're going to reward the agent more and significantly more if it goes over the straight line. I'll just make a quick stop here for any questions before I move into the next slide.
One question we've got coming through, one, Carlos, is whether the cars can be purchased from Amazon Australia. I've had a look and I can't see any, so I think the answer is no at the moment. We might want to check into that, but I've put links to both the Evo and the original version on the US site. Alan's asked, are the weights kind of arbitrary? And I assume Alan, you talked there about the reward points for each zone. Yeah, so the question there is, the reward points on that grid you've got there, are they basically arbitrary?
Yeah, they're pretty much arbitrary. So probably the ones that we are using in here are what we use during the creation of the rewards function. However, the opportunity with this exercise in here really is for you to explore, right? So we encourage you to try different things and yeah, learn how it behaves.
Another question from Rashik is the X's in those purple spots. The question is, does that mean 0 points of reward?
Great question. No, in this particular case, they are just simulating the off track. So in order to simplify the example, we just use the points in the middle. Thank you all. Is that all, Jenny?
Yep, that's it for the time being.
Okay, cool. I move into the next slide. So now try to think from the agent perspective. When it starts to try things, it'll probably start like a little bit dumb, right? It doesn't know exactly what actions are going to generate more rewards. However, as time passes, you will see that the agent starts to say, okay, if I go through these particular points or squares, I will generate more rewards. So after several episodes and iterations, it gets to a point where it understands that the majority of points are going to be reached by going down that straight line. And that's how actually your car is going to behave as well with your model. So, exploration versus exploitation. If we could be sort of at the same level of the car, and if we could look at what it's doing, during the training, it is doing exploration. So it'll start doing random things and then figure out what's that environment and how it can get more rewards based on behavior. So you will start seeing that the car just starts and getting off track. Sometimes you will see some progress, but then it goes backwards again. That's the exploration stage. After several episodes, you will start seeing more of the exploitation behavior, where there is some learning already, and the car starts to go within the track. Depending on your reward function, the car will exhibit more or less speed, or being more cautious about not getting off the track. And you will see a couple of algorithms where you're going to be able to link that to this particular slide. So how does the learning actually happen? So we have in here the agent, we have the environment, and we have status that we are defining at a particular point in time. The agent is going to execute an action, and then it'll move the status to the, or will generate the next status for that particular point in time. Then, via the algorithm, the agent is going to get a reward. After several actions within that episode, the car is going to learn what actions start to generate the more points. And as you go through multiple episodes, you start to convert into a particular model that is actually what you are going to use in your car, in your virtual or physical car. That model is what will determine what actions the car is going to take based on the images. I'll just make a quick stop here as well for more questions.
There's no questions at this point, I don't think.
So what is behind the scenes? So what it is using is a neural network. So we have the input. We have a CNN convolutional neural network. You have the option of selecting a 3-layer neural network or a 5-layer neural network. The one that we are depicting in here is the 3 layers network. And this one is suitable for not too complex reward functions. So if you are not using that many features and your reward function is not too complex, probably this is the best way for you. If you start to add lots of information, or you, for example, are using your LiDAR sensor and obstacles in a particular race, you probably are going to be better off by using a deeper neural network. Once the model starts to converge, then there is a policy network that generates and weights what is the action for a particular set, of images. And that's exactly how the network gets that knowledge as more episodes happen. We'll just make a quick stop here for any questions.
Yeah,
So,
one pass.
Okay,
you go.
Okay. I'll just go. So yeah, one of the questions was, do different tracks require completely different models?
That's a great question. So in general, the answer is yes. However, if you could create a model that is so good that it is agnostic of what the track is, that'll be awesome. Most of the time, you will see that there will be some overfitting, where overfitting means that the learning gets tied to a particular environment. So most likely you are going to notice that your model for a particular track is not going to do as well if you run it in a different track.
And Juan Carlos, I just dropped a comment on this too, that you can actually clone a model. So say you've trained a model on one particular track, you can clone that model and then train it on a different track. And then it's going to learn basically a mix of all tracks. So that can lead to quite a good model. But if you've got a track with, lots of very tight left-hand turns, for example, and your model was trained on a track that's got fairly gentle curves, it's not going to do too well. But you can clone it and train it again. And that's really part of the experimentation phase. We can't necessarily tell you whether it's going to work better or not. That's kind of what I love about this. People teach us, they try different things and let us know what has worked.
Excellent point, Jenny. Thanks a lot for bringing that up. So that's quite important. So you can sort of use, not only for a new track, but you could use a previous model that learned on one given track and then use that information to improve that model without losing the previous learning. So encourage as well, as Jenny mentioned, to explore that. So the AWS DeepRacer Console. When you get into Andrew's section, you are going to see that you have a single interface for DeepRacer. So, but within this particular single interface, there are several services behind the scenes. What services do we have? So you see at the top Amazon SageMaker, and Amazon SageMaker is doing the training and generating the model. Once the model is complete, the model is stored in Amazon S3, and that's the model that you take for your car. So you upload that model into your virtual or physical car. So, but you also see AWS RoboMaker at the bottom. RoboMaker is creating the 3D environment. So you will see that there is a lot of interaction between RoboMaker providing information about what the current status is, and Amazon and SageMaker go back and forward in regards to sharing that information. There are two more services that are part of this of the DeepRacer. One is Amazon CloudWatch, and it gives you the logs of what's going on. And another service called Amazon Kinesis Video Streams. It would give you the chance to see what is happening in the virtual environment. So it shows you where your car is. So the images that I showed you before during exploration and exploitation are imaged out of Amazon Kinesis Video Streams out of AWS RoboMaker. So this is the real bit where you're going to make a difference. So this is the reward function. As I mentioned before, you use Python 3 for this. Again, Andrew's going to go into more details about it. But you have example reward functions. We provide you with 3 examples. You don't have to start from scratch. And we also give you a validation function. So rather than you trying something that is not valid, we give you the opportunity to check that before that function goes into training. For you to configure your reward function, there are some concepts and variables that are very important for you to know. So we're going to describe those. The first one is the track wall, which is that bluish area that you see at the top. Then you have the off track, and that off track is the green area. We have the on track area, which is that gray area, including the white lines on the sides, which are precisely the track boundary. And we have these orange dotted lines that define the track center. Now, you don't need to memorize or learn all this, and Andrew will also show how to use them, and you will have time to learned and read about some of them. There are some other variables in regards to the status of the particular car at a particular moment. The first one is coordinates, right? Your X and Y coordinates measure from a particular point, and that tells you in what specific location the car is. Something that is very important for me to mention at this stage is that all this information that I'm describing now is available during training only. So once your car is in racing mode, either virtual or physically, the only information the car gets is the images. So you only have access to all this wealth of information for training, and nothing happens. The car is not learning anymore during the racing time. We also have the heading. We'll give you an angle of where the car is heading to. It is measured from the X axis. Another variable is waypoints, and you can also get the closest waypoints from your car. And waypoints are points that are defining specific positions within a particular track. So for example, in this tracking here, we go from 1 to 13, and it gives you the position of the car. You can use that as part of your reward function as well. This is a Boolean variable, all with wheels on track. So if the car goes on track, it goes false. If all the wheels are on track, it gives you true. This is very straightforward. This gives you the track width. This variable will give you the distance from the center. So if you are using functions, for example, where you want the car to stay closer to the central line, you probably will be thinking about providing rewards to being close to the central line and maybe less rewards if the car goes too far away from the central line. And speed, of course. So you also have that option about checking information and of course checking information about the speed of your car. You have the option to customize your car. So once you get into the console, you have the option to define your car. So you can use 1 camera or 2 cameras. For this event, I think we're using only time trial. So that really is up to you. I'll leave it up to you to decide what things to use. Probably the LiDAR sensor is not going to add much value, as there are not going to be any obstacles as part of the competition. And in regards to the action space, you will have the steering angle. You have 2 options actually. So you have discrete and continuous. If you use the discrete, you have only a number of granular options for steering and speed. If you don't want to have that, if you want to have, so the total number of continuous options for steering or speed, then you can go continuous. The difference is that probably your model is going to be simpler if you have a reduced number of options, which means that it may take less time to train. The more options you provide will imply that it will probably take longer until it learns, as there are more variables to play with for action points. Okay, a quick stop here for any additional questions.
Just give it a few seconds, see if people are typing, but there's no questions at this point. Yeah, it seems like, yeah, there's no questions at this point so far.
Okay, thank you, Andrew. So we have for 2021, so we have the open division and the pro division. The suggested division for beginners is the open division. Pro division includes not only time trial, but also races with obstacles. So it's really sort of the next level and really cool to participate. You get digital rewards in the official league. So you may get a car avatar or different colors as you win races. And you also have events where you have celebrities, and you have the option to participate in the reInvent 2021 championship. The community league races, they were recently introduced. They give you tools to manage the race, and they have multiple options. Like, for example, rather than having a single race, you may have multi-race events, and you may also have like seasons, right? Like, I don't know, you may define multiple races and then season 1, and then another season of a few more races. So you have a lot of freedom in regards to how you want to define those particular leagues. You can also broadcast to Twitch if you want to provide your community with information about what's going on in that particular community race. Additional resources. So there is a Slack community that you can get information from. Of course, GitHub. There is enough videos and training. Even within the DeepRacer Console, there is one video for training if you want to get more information, or if you want to just refresh your knowledge. There is a website with tips, forums, and if you want to know more about OpenVINO, there is a link as well over there. With that, I'm handing over to Andrew for the fun stuff, and it is getting your hands dirty with the console and how to participate in the race. Over to you, Andrew.
Thank you. Awesome. So I hope everyone learned a lot from what Juan just showed you all about DeepRacer. So right now, just let me share my screen just very quickly. Okay, let me just get things opening, and then I'll just share my screen. Desktop 2. Share. Okay, can everyone see my screen at this point?
Yep.
Awesome. Okay, so firstly, so for this particular session, we've actually created events for you. So like an actual AWS account, so you can use it. So can everyone still see my screen overall? Yep. So it's something called an Event Engine account. So I'll paste all these links afterwards. I'll just give you an explanation of what you need to do to access your AWS account. So firstly, you will need to navigate to this corresponding link. And then there's a particular hash that I'll give everyone. And people will just need to input this hash. And then after that, click Accept Terms and Login. After that, there will be an email. So click into email one-time password, place in your email so that you get the one-time password and log into the general console area. So I'll just copy and paste the general links firstly within the Zoom Chime window so everyone understands what they need to do, and then we can go from there. So let me just give me a sec. Just trying to, let me stop the share first so that I could get that window back up. So I've just pasted it within the Zoom chat link. So that's the link, and then that's the event hash. So place it in and then see if there's any problems. If there's any problems, we're on the board to help. So I'll give everyone a few minutes, like 2 to 3 minutes. It shouldn't take too long. To get up to the stage where you can start inputting your email. So I'll share my screen again. Yep. And then so let me just expand this, might be easier. So once everyone has inputted the link and shared the overall, gotten the one-time password, what you should be able to do is you should be able to see something like this, like a team dashboard. So firstly, for your team dashboard, you should be able to set a particular name. So I think it was under the dashboard. So try to set the name to one of your names so that we can identify you, so that if there's any problems later on in today's practical session, we can jump into your account and help you. So make sure to see if you can find that overall name setting. And then apart from that, you would be able to click directly into AWS Console. So I'll give everyone a few minutes there just to get everything sorted. It might take a few minutes for all the emails to come through.
A few of us are getting event not running.
Oh, okay. Yep. Okay. Thanks for pointing that out.
Mm-hmm.
Apologies for that. It's already set up. I just forgot to click start. So let me just click start, and it should be up and running in a few seconds. So let me just start it. Yep.
Perfect.
So
now
it works. Yep. Awesome. So I can see there's a few people already logged in and getting ready. So I'll just give everyone a few seconds more just to log in and then get into AWS Console. So what you want to do is you want to click AWS Console after this. So when you've logged in, click the AWS Console, set your name. This is what should show up. So I'll just pause here for a sec just to see if there's any particular questions. Juan, are there any particular questions within the group chat or anything, or is everyone smoothly going through?
Yeah, no questions as yet, but I think that let's wait a couple of minutes to give time.
No problem. Let's wait 2 minutes. Yeah, I can see that one person hasn't fully logged in. So they've claimed it, but they haven't logged in. So we can see if that person can wait a bit. So for people that are waiting, just in general, I'll just give you a brief overview. Like apart from DeepRacer, we actually have a lot of other different sorts of services, as you could see here. There's quite a bit. And all these services, depending on your use case, some are for creating servers like EC2, some are for storage, such as S3, and some might be for networking, like VPC. This one, I'm not sure if people paid attention during the presentation, but Juan actually mentioned Amazon SageMaker as one of the more deep sort of machine learning services that we have that allow people to actually code up their own machine learning models. So this is Amazon SageMaker that people might also be interested in looking into as well. So I'm assuming that everyone was able to get to this management console page. So let's go through exactly how we get to DeepRacer. So there's two ways. So if you've accessed it before, the first way is already within this recently visited services area. Otherwise, just type it up here. So AWS DeepRacer. And then here you go. You see DeepRacer. So within here, there's actually a lot of information. So firstly, let's expand on the left-hand side. So you could see a lot of different sorts of options, as well as, just to create a model aspect. So firstly, what I want everyone to do would be to actually create your racer profile so that we can identify who the actual racer is. So when we're competing in the actual, race, you'll be able to be identified.
Sorry, Andrew, there was a question about how do you change your name?
Yep. So within the racer profile here, so the racer name, once you've set it, you actually can't change it anymore. So make sure that you set a corresponding name so that, you will be able to identify you after. So this is where the racer name is, and you'll be able to set it initially overall. So I think a lot of people just went ahead, which is fine. But yeah, if you've set your name, that's fine. We can always identify you after, but I was just asking the general professor just to see who is the actual racer. But make sure that you can actually, customize your avatar here. And this is just your racer profile that you will use for your actual race. So that's the racer profile. And then after that, you want to, for example, create a car, right? So actually, let me just start off with, creating the car. So creating the car starts off with this overall garage. So you can create your DeepRacer car. So you can see that I've created a few. So I could build a new vehicle. And for this use case, I'll say UTS AI, demo. So this is just for you to customize your car if you want. And then you can just customize different sorts of colors that you would like for your car. And then you can click next after that. For the benefits of this particular race, there's no need to add the stereo cameras and the LiDAR sensor. So stereo cameras and LiDAR sensors are more for a different sort of race. So there's a few races that we actually have. So we have like time trial, we have object avoidance, as well as head-to-head. So stereo cameras and LiDAR sensors are more towards when you're having head-to-head and also object avoidance for the races that we'll be doing. But for this particular showcase and this competition that we're holding today, we're only using camera. So it will only be a time trial and there will only be a particular camera right in front of the car. And that's how you'll be training it. After that, what you want to do is click next. And this is the action space. So this is the action space that Juan was talking about prior. So there's two, there's discrete and there's continuous. So you can definitely read up a lot more details than what I'm going to provide to you today. Apologies. What I'm going to provide for you today in terms of the action space, but just a brief understanding of it. So the discrete action space means that for each particular number, the car will only move at this corresponding degree, like at -30 degrees, only at the speed. So what the actual reinforcement learning model will do will be, it will calculate the overall optimal action number to undertake based off particular scenarios. And that's essentially what the discrete action space will incorporate. And you could see here that you can actually change the maximum steering angle from 1 to 30. You can change the granularity. So I can make it more granular and overall change even the speed, right? So that it slowly navigates through the curves within the actual track. So that's for a discrete action space. And then there's also a continuous action space. And continuous action space just means that the state is based off a range of values, right? It's not set, right? So based off the overall reinforcement learning understanding, it will undertake a particular continuous method of steering for the actual car itself. So are there any particular questions at this point in time?
Nothing on the chat window.
Okay. So let's just create a discrete action space just for demonstrations purposes. And then we just click done. And there you go. I've created my actual car, my pink UTS AI demo car. And once you've created your car, you can also actually mod the vehicle and change it again. If you want, later on, you can add cameras, you can also change it from discrete back to continuous if you want. So it's very flexible. So once you've created your car, what you want to do is you actually want to create your reinforcement learning model, right? Because just having a car by itself doesn't just drive by itself. You actually need to have a model on it. So how do you do that? So there's two ways. One is create model. One is get started. So I would advise everyone to go to get started because there's actually an interesting course here. So this is the crash course. So it's 10 minutes, super simple. And it actually just teaches exactly what Juan was explaining. So let's click into it and I can show you just very briefly. So there's like videos, there's an explanation again about what reinforcement learning is, the action space, and the rewards. As well as it also explains to you like how the simplified environment works, how it slowly goes through each episode and iterates through the reinforcement learning just to get to the final finish line. And then as well as explaining to you what the parameters actually mean. So all the particular sorts of animations that you saw within the slides from Juan, you can also see here. So it just explains to you all of it and how it actually calculates the heading and those sorts of things. So this is just the getting started aspect. So for anyone that wants a general refresher, maybe after like half an hour, you're not too familiar, you can definitely go into here and look into it again. After this, so after you understand at a high level how everything works for reinforcement learning, we can finally create the model. So we click create model. And let's, for example, the name is UTS demo. You can give it a description if you want. And this is where the interesting part is. So there's a lot of tracks here, and I've actually received a lot of different sorts of queries from different participants asking, oh, should I pick another track to the one that we're competing on, right? So usually how it works is that the more tracks that you train your model on in different scenarios, the better it is, because of the fact that it's able to, understand different scenarios in the racetracks. And it's able to understand how to turn really tight corners, right? Whereas if you just trained it on a very simple track, like these ones, right, and overfit the model, what that means is that it will only know to always go around not as steep sort of curves. Whereas these ones, it will understand how to do very tight turns. So you can experiment and try out your models and see how it performs within the competition. But for today's competition, what we're actually competing on is this one, the 2019 DeepRacer Championship Cup. So that's the track that we'll be competing on for the actual competition that I'll send to everyone later on. So after this, after you pick the track that you want to train your model on, what you want to do is you want to click next. And over here, what we're doing for today for the competition is time trial. So it's not object avoidance, it's not head-to-head racing, it's just time trial. And then there's also extra tweaks in terms of the hyperparameters, as well as the overall algorithms that you want to use. And there's a lot of documentation regarding how you want to tweak these sorts of gradient descent batch sizes, the overall step sizes that you overall have for your reinforcement learning model, as well as the learning rate, those sorts of aspects. So you can we have a lot of documentation that I can send to everyone within the link as well, just to understand a bit more of whether you want to tweak it. But for just starting off and just understanding how to play around with the model, I'll just set as default. And then you could see here that I have a lot of different cars. So let's just start off with UTS AI demo. Click next. And this is the reward function. So we were talking about from Juan that the car will continuously drive in different ways based off exploration and exploitation. And based off these two sorts of behaviors, it will gain particular rewards. And that's where the reward function comes in. So if you click into reward function examples, there's already examples present. So you could see here, these are for time trials, and this is more for object avoidance. So this is just a starter template so that everyone kind of understands what the reward function is. So let me just quickly, very briefly explain to you what reward function is. So for this particular case, you could see here, what it's trying to do is there's a track width and there's the distance from the center. And what it's trying to do is it's trying to create markers from the overall track width. So there's particular markers on the track width, and it's trying to compare whether your actual distance from the actual center and the marker, whether it's less than the overall marker, so whether it's very close to the center or whether it's very far away from the center. So if it's very close to the center, so marker 1, if you can see, it's 0.1 of the track width. So it's very, very small, right? And the distance is very small from the center. So it means that the distance from the car and the center is very small. Then I have a reward of 1. Whereas when it gets bigger, in terms of further out, the reward decreases because I'm deviating from the center. And in general, what I want my reward function to do is that it needs to always stay on the center line. And that's what it's trying to do in terms of these markers. And then at the end, if the distance from the center is more than 50% away from the track width, so it's veered very far out from the actual center line, it means that it's probably crashed or it's very close to being off track. So we actually give it a very, very small sort of reward. And what the algorithm will try to do, it will try to maximize the amount of rewards. So just based off a simple mathematics, overall, try to maximize the general rewards. And through that, it will undercode the corresponding behavior and change. And then, so these are all the reward function examples. So what I would advise people to do for people that are not as familiar with reinforcement learning at the start, just try tweak around with the rewards, right? So just set very low, or maybe even set this one really high and set this one really low, right? What does that entail in terms of the final training? Does it mean that it will always veer off track, or will it still always follow the center line? Try to experiment and understand a bit more about how the model behaves. And then when you also modify it, also understand that the syntax can also be done using this validate on the right-hand side. And this is just in Python. And then you can click validate here just to see exactly whether the syntax is all right before training your model. Over here is the stop condition. So what the stop condition is the overall time that you want to train your model. So right now it's set at 1 hour. We would advise that the minimum is to train it for 1 hour. But for example, if you want to also test how the model will do if it was trained for only 5 minutes as compared to 1 hour, you can also do that. And you can compare and see how your model actually performs and behaves. You can also submit it to a DeepRacer League, but for demonstration purposes, we're not really doing that right now. And then it's just for 60 minutes, and then we can just create the model. So are there any questions at this point in time, Juan?
Yeah, there were a couple of questions in the chat. So I already answered to the first one which was about if the model actually learns of just memorized. I provided an example that it actually learns, but if the whole environment is very specific, right, it wouldn't learn about the whole possibilities. So similar to like a tennis player that plays always on clay. When that player is going to play in a different court surface, that player may struggle a little bit. I also provided a link over there. There's another question that I was just about to answer in regards to the reward always being positive. What we have found is that it seems to work better if you provide positive rewards, but it doesn't have to be. So we encourage you to try different things and even different models to see how they behave.
Okay, yep. Any other questions? Those main two.
Those two, there is another one from Adam. So what are the rules for a successful run? Does the car have to stay on track?
Yep. So the rules for a successful run. So right now it's training. So I'll just go to the actual race that we've set up for you. So this is the race that we have. So right now, what it needs to do is it needs to be able to undertake. So here, it says the rules are all here. So it ranks based off the total time. It needs to have 3 consecutive laps. Every time it goes off the lap, there's a 3-second off-track penalty. There's unlimited resets, and you can, enter as much as you want in general. There's no problems there. So what I'll do now, so once you've actually trained up your model, so this one is the one that I'm currently training. So for example, this one is already trained. What you want to do is being logged into your current AWS console, you want to enter this corresponding link. So just go open a new tab and just place in this link. So let me just paste this in. Let's see. Let's go chat. So this is the competition link. So once you've placed it in, for example, I can click into it. right? And what it'll do is it will take you exactly to the race that I just showed you. And you can enter the race by clicking the top right-hand side. So you can enter the race, and then you can choose your corresponding model. So I'll give you a demonstration. So for example, I have this race. That's the race demo. I want to enter the race. And then I can put another model, like for example, this one, and I just enter the race. And that's how you enter the general race. And then your model was submitted. And then it takes around 10 minutes for it to try to race against the track. Once it's finished racing, you can actually see the racer name. So the racer that's actually on the top of the charts, the time, as well as the model that you've last submitted, right? As well as you can also see a video of how that actual car performed. So you could see this one's not performing too well. It keeps on driving off. So this is just how I've trained it. And it's not the best. And you could see that the reset's being 14, but it just continuously just goes off track. So that's how you would enter the competition. So just click into that link once you've trained up your model, and you'll be able to enter into this UTS AI Showcase race. So this race will end at midnight tomorrow night. So people can train as much as they want, play around with as much as they want for the UTS General DeepRacer Console. So are there any questions right now?
Not on the chat yet, but let's wait maybe a minute to see if there are more questions.
Yep. Okay, so there's a few questions that came up. So how long does it take to train the models? So the minimum that you can set it as is 5 minutes, but the maximum is 1,440 minutes. So I believe that's 24 hours, I think. So that's how long it takes to train the models. And obviously, the longer you train it, there's going to be that overfit and underfit sort of model problem that you have. How many times can we enter the race? At this point in time, there's no limit on it. You can continuously enter it. I haven't set a limit on it, so just continuously enter and just play around. Should we limit training? Default is 1 hour. So that's the beauty behind it. There's actually no optimal way of training. Like people have had different ways of training and still gotten very optimal results. So I wouldn't limit training to only 1 hour. Experiment. And you can actually train in concurrency, right? So you could train the model under this specific set of parameters and then train another model very similar under another set of parameters. So I would say train models concurrently so that you'll be able to make the best use of time. So I can create another model right now and do exactly the same thing.
Andrew, I think something I'd say is please do experiment, just as Andrew said. Look, we've seen people have good success spending about 2 hours on training. And then, you might want to clone that model, have a slightly different reward function, or, maybe even a different track, and do a couple more hours. But yeah, typically, experiment, but you might want to start with a couple hours.
Yep.
Yep. There's another question around.
Actually, 3 more questions.
Yeah, I'll let you handle them.
Yep. So how to visualize my model performance or view the models once they're done training. So you can see here. So there's one that's been done training. You can actually download the logs to see how it actually performs. But live, so I can click into it afterwards, but live, you'll be able to actually see a simulated video stream of how it's actually moving. And you can see the general average completion rate of the training in comparison to the actual evaluation and the average rewards that it's getting. And then you can actually evaluate it as well, right? So you can evaluate it based off the actual model, and you can evaluate it against particular tracks just to see how it performs for particular tracks in terms of time trial, those sorts of things. This is just to make sure, the evaluation is just to make sure that you haven't overfit only for one particular track, because if you see your evaluation, it performs really poorly, you might have overfit it. Any recommended hyperparameters? So the recommended hyperparameters right now, like that, I'm pretty sure, like even if you ask the most tenured person for DeepRacer, there's no full recommendation on hyperparameters because there's just so many different techniques. So at this point in time, unless Juan, do you have any particular experience with specific hyperparameters?
I probably will suggest just that maybe start with the default parameters initially, and then as you start to learn more, probably start to play with them. Again, so the idea out of this really more than winning the race is really the experimentation bit, as highlighted by Jenny. So I'm really encouraging you to just try different things.
Mm-hmm. And then
I might just add something to that. Yeah, I agree. Those hyperparameters have been selected by experts. You're probably not going to get much benefit by changing them. Where you're going to get the biggest bang for your buck is with the reward function. If you absolutely wanted to fiddle with a hyperparameter, the one I'd recommend would be discount factor. You can think of discount factor as how far into the future do I look when determining whether a move was a good move or a bad move. If you reduce that, say, from 0.99 to 0.99, 0.9, or maybe even 0.8, your model will look less into the future as it's determining whether a current move is a good move. But by doing that, it trains a lot faster. So I've seen people get actually good results with a discount factor of as low as 0.7, believe it or not.
So there you go for the person that asked. And then for the last question, how do we train a model on multiple tracks? So what you can do is that once you've trained a model already, what you want to do is you want to clone it. So this one's already been trained on one particular track. You would clone it, clone the model, and then place it on another track. So put it on another track, and then that way you'll be able to further train the model on multiple tracks. Yep. So one person was saying, how long do we have access to this AWS DeepRacer? Is it until the deadline? So the community race, so this race is until the deadline of 11:59 p.m. And I believe the actual labs themselves, let me just double check on the labs. So just say it's around 11:59 p.m. tomorrow as well. So it's just when the whole event just concludes and finishes. Is there any way to download the model, TensorFlow, and run our own gaming or CUDA rig? Okay, so that sort of complexity will probably delve into, so you can actually download the model, I believe. So let's see. So if you click into here, yeah. So you can see here, you could download the actual model and then you can tweak with it. You can tweak it and play around with it. That's definitely possible in terms of if you want to play around with the code and understand it a bit more. But we would say if you're just starting off, just try to use the console because there's a lot more intricacies that have been explained today in terms of the actual coding behind it. So 2 people. So one person was asking, will you only be able to see the community race once you make your model? No. So the community race, I just shared a link. So I'll share a link again. So the community race, you'll be able to see it. You'll be able to enter the race once you've created the model. This is the link. So click into the link or save the link so that after your model has been trained, you'll be able to enter the actual race. How long does it take to initialize? Is taking longer than expected. Yep. So it does take a while for it to initialize, but if you look into my one right now, so it's already training. So it does take a bit of time, but be a bit more. Yeah. So you could see here, there's the simulated video stream, but yeah, just give it some time, and it will definitely be able to train up the model. How to delete a model or stop training? So once you've trained the model, that's a good question. To actually stop the model, I believe, yep. So I believe there's no particular way to stop the model unless you, wait, let me just double check. Yeah, I believe there isn't any particular way to stop the model once you've already once you're already training it. But regardless, I feel like you can just create a brand new model, right? Like once if you, for example, click the wrong thing, just create a new model and just train it again. There's nothing like it won't hinder another new training, is what I'm trying to say. I hope that answers a lot of the questions. Any other questions? Okay, seems quite quiet now. But yeah, Jenny just shared a link as well on a deep dive on the actual intricacies behind the model if you want to tune that as well. That's probably beyond what we've elaborated on today, but definitely encourage everyone to read into it and analyze a lot more behind the DeepRacer to see how the model can get trained in a very positive fashion. So apart from that, what we'll do is right now, we'll just stay on the line just to assist for any sort of problems that people might be having for the models. So right now, what I'll do is I'll send everyone the links again for anyone that was late to join or didn't see the competition link. So there you go. So this is just a rehash of everything that I've just explained. If you want to have an AWS account, click into the Event Engine dashboard, place in your event hash, and click on AWS Console. And there you go. You'll be able to access the AWS Console. And then once you've trained your model, click into the bottom link, the bit.ly link, and you'll be able to enter the actual race. So we'll be announcing the winner for this race after tomorrow at 11:59 p.m. So this is when it'll end. If there's no other questions, then we'll just stay on the line for the time being until, we'll just stay on the line and then just assist for any sort of problems that people might be having. But I'll pass it back to Nabin, I believe. The prize for the winner. That's a good point. Okay, so for the prize for the winner, what have we decided on, Juan? Jenny, have we decided on the particular prize at this point?
I'm not sure. Tash was organising that, so we'll make sure there's a prize. Yep.
There's definitely a prize. Don't worry about that. Which is
why. Is Nabin there? Are we allowed to do prizes? How about we arrange an Amazon Echo Dot for the winner? Would that be okay?
Yeah, absolutely.
Okay. All right. Let's do that.
Sounds good.
Thank you.
So there you go. That's the prize. So happy racing. And then we'll just stay on the background. And if there's any other issues, we can we're more than happy to help. Pass it over to you, Nabin. Thank you.
Thank you so much. It's wonderful. Okay. Do we have any questions? How many of you have managed to start training the agent?
The chat box is disabled, so if anyone's typing into chat, you probably won't get anything.
Is it disabled? No. Yeah, it should be okay.
It's probably because you're host and co-host.
Okay. It should not be the case because
On my screen, it has where you type in the text, chat disabled, and no option to actually put in text. So you might find that might be disabled for other participants.
Yeah, it's disabled for me as well.
Everything looks good on my side. Can anyone else try? Githard, Shraddha?
I think you'll have to check the security and allow everyone to chat, maybe.
Yes, that's fine. I think I will just check it. Yeah, it's allowed. It's a bit strange.
So to me, it still shows the chat is disabled.
Okay. No idea what went wrong. How about now?
Yeah, it looks
It
fine.
is fine now.
Okay,
Yes,
good,
it's good.
wonderful. So, question time, please.
I do have a question for you, Narbin, outside
Yes.
of this workshop or the AI presentations.
Yes, if it is relevant. Or we can take it offline.
It's relevant to those who have who had presentations later this evening.
Do we have presentation later this evening?
No, like the ones that have been postponed.
Oh yeah, I think if you have registered, you should have received an email. We don't have the showcase running, the project showcase running today. It will be scheduled on a different date.
Yeah, so I had a question about the showcase on the night it would eventually happen.
Mm-hmm.
So for our groups, ours is a mobile app.
Okay, Michael, I think we can take it offline.
All right, sure, I'll
Thanks.
contact you later.
Not a worry. Okay. So we have a few questions there. So regarding DeepRacer training, are there any limitation on how many models we can train or max number of training hours?
So max number of training hours, I believe, is set to 24 hours for every model that gets trained. That limitation will change depending on if it's external to the console as well. But from the console, I believe it's 24 hours. And then
that's for a single training. So
yes.
if you were to clone it, you could throw another 24 hours on it by cloning it and starting it again. Yeah.
For a single model. And then for how many models we can train at any one time, I'm not sure about that limit. That's a good question, actually. Would you be familiar with that one, Jenny? How many models they can train concurrently? Is there a limit?
Depends on hardware, GPUs. No.
That is definitely a limitation. But
couldn't work out how to unmute myself. Sorry. Yeah, I'm not sure. It used to be 2, then it lifted to 3. At one stage it was 1. I'm honestly not sure. Just give it a try and see how many you can train concurrently. I mean, obviously there's not much point training a model that's got exactly the same reward function on the same track. You know, you might try a few different reward functions at the same time. And I guess my tip there is be really verbose in the description of your model. Like really be clear on, you know, what you were doing with your reward function, you know, during the training of that model, because you'll come back later on and go, oh God, I can't remember anything about this model called blah, blah, blah. So yeah, do that. But as for number, you can train concurrently. Can someone just give it a go and let us know? I'm sorry, I can't remember.
And there's one more question. Yeah, so for Salim, yeah, just try. I'm pretty sure you could definitely train like 3 or 4 That's quite a small number, in all honesty. Yes, and there is no charge for the training of the models for the competition time duration because you're using our AWS accounts. So use the accounts that I provided to you via the links before. Otherwise, if you use your personal accounts, there will be charges in place because you're not using our AWS accounts. And then one person was asking, in regards to landing graduate jobs or internships, is it better to be highly specialized or have a solid fundamental knowledge in multiple languages of software? So I think the first question that comes to mind for me is, in particular, what particular role you're looking into within graduate jobs or internships, because depending on the role, there will be different sorts of requirements. I think the stock standard answer in general for any sort of graduate job is to always have a solid fundamental knowledge, regardless of whether you land the job or not. Having that solid fundamental knowledge will allow you to excel a lot more within the general workplace, given that a lot of new technologies, you'll be learning a lot with new technologies, and they're always built on the fundamentals. Hope that answers that question.
Yeah, Andrew, that's good. I might just reiterate exactly what you said there. We do find it's hard to hire good generalists, people who can be across a lot at AWS. Being a specialist, you go obviously going quite deep, and that has its own challenges. But those general skills are incredibly valuable. So do not discount being a generalist. It's absolutely what we look for.
If I may just add to that, Jenny and Andrew as well, that probably, so in addition to specific knowledge, the mechanisms for you to solve problems and the way of thinking is something as well that is very relevant. And of course, normally those things are really outside of a specific specialist areas.
Thank you. Any other questions, please? I think maybe I can ask a question.
Sure.
So what my students always ask me is about internship opportunities. So do you have any insights on if there are any internship opportunities for students with AWS?
I can answer that. Yes, we absolutely do internships. It's a great way for us to build our pipeline of talent. We typically take interns at the end of the year or beginning of the calendar year, and we have a manager for that team. So very happy for, I think the account manager you work with is Jim Manning. Jim can make that connection.
Yes, Jim.
Yep. As the guy's name who manages that team, his name is Mark Seddon, Seddon. So
okay.
We'll be taking interns at the beginning of the new year. Do we accept international students as interns? Yes, we've done that before, so that's fine.
Wonderful.
There's a question from Rashik in regards to the DeepRacer model. If you choose to increase the speed, does it sacrifice the training in any way? Rashik, I think you're talking about the maximum speed. Yes, it does. If you set that maximum speed to the maximum value, which is 4 meters per second, you can imagine, in the virtual track, it's running around really fast. It gets to make a decision 15 times per second, but if it's traveling at 4 meters per second, it's only getting to make 15 decisions every 4 meters, which, to be honest, isn't much. So by setting it 4 meters per second, to be honest, try it, but you're probably going to get poor results. If you want my tip, I'd suggest keep it below 2.
Wonderful. Thank you. Any other questions? Okay. If we don't have any other questions, shall we? How is the training going for everyone? I guess it will at least take around 1 hour.
So actually, so one thing I did want to point out, so courtesy of Melwin, so Melwin actually found out one of the answers for the quotas. So it looks like just based off a default AWS account, you can only have 4 training jobs at any one time for training concurrently. I believe these sorts of accounts are also defaults, so it should be 4. Tell me otherwise. If you can trade more than 4, but from just our knowledge right now, in terms of information, it is only 4. So you can train 4 models concurrently at any one time. And then apart from that, so some people were also asking about whether we can learn about AWS, practically. So something that Melwin also pointed out. So we do have a free tier on AWS. So if you want to look into that, as well as AWS training, those are 2 sorts of resources that you can access. And one more that might be interesting for students at UTS, I believe some of you might have heard of AWS Educate. If not, have a look into it. AWS Educate. So AWS Educate is for students to look into sorts of AWS and how the cloud actually operates. And it's more of a learning sort of platform that would benefit anyone that wants to learn a bit more about the cloud. One person did ask, if we close the browser, does the training still continue? Yes, it does. That's one of the beauties behind cloud. So everything is operating in the cloud via API calls, those sorts of things. So even if you close the browser, the training is still continuing. Okay, I think that's all I want to point out. Yep, so someone did confirm it. So it is a max of 4 models concurrently. So thank you for that. And then, yeah, so some people have said that they use the AWS Educate for academic staff. Yep. Okay. That's good.
Thank you, Chris.
Thanks, Chris.
So I think even my students in my class, deep learning and CNN, some of them do use the AWS Educate account.
Yep, that's good to hear.
The other question is, how about, do the students get access to free GPU or EC tools, basically?
So regarding that, are you referring to AWS Educate, or are you talking about free
yes,
tier?
From AWS Educate.
So for AWS Educate, from my experience, I believe there's a limitation on how it works for the overall GPUs, whether it's an actual training or an inference job. So there will be limitations regarding that. I think it's best to talk with Jim regarding interest around that, and he'll be able to connect you with the corresponding program manager to look into it a bit more.
Wonderful. Thank you.
Yeah, I think that's all the questions at this point.
Yes.
Yeah, I'll just go back into the background, and if there's any other questions, I'll just pop right back in.
Yeah, we're gonna stay for a few more minutes if there are more questions about the training.
Yes. Sure.
Nabin, I was going to ask you, do you work with Nils de Vries from AWS?
Yes.
Yeah, okay.
Yes.
I'm going to
Niels,
contact...
Jim, both of them. Yeah.
Excellent. I'm going to contact both of them, and when there's a winner, if you let them know who the winner is, they can get in contact and arrange the prize to be sent.
That would be wonderful. Thank you so much.
Great, no worries.
And I guess we still have the AI project showcase in the pipeline once the restrictions are a bit relaxed. So we'll organize that on campus, and potentially on that day, along with the other prizes that we have, we can hand over that prize as well for the race.
Excellent. Yeah, and hopefully in future we can do this with physical racetracks and cars, you know.
Absolutely.
And
that
just when we do, yeah, I know. When we do that, just bear in mind the racetrack does require a space of sort of a very, very minimum would be 8 meters by 6 meters. Really, 9 by 7 or bigger is better. So just keep that in mind for future events. Yeah.
Yeah, I think if we get the 8 meters by 6 meters track, that will be the best one, I guess, because I've been, moving around and finding space for the bigger one, but I think the 8 seats would be the best one.
Let me find out the exact measurements just while people are working. I can't remember exactly what it is. I'll find out.
Thank you. Okay, I think is there a question there? We've been using the down track for Robotics Studio 2. Alan, is that quite big?
Sorry, yeah, we have probably about 6 by 4 total area.
Okay.
Yeah, but it doesn't use cloud services. But the idea to use it for reinforcement learning is the same. So I can see this has got advantages that it's got a good simulator.
Yep. Wonderful. I think if we don't have any other questions, shall we conclude the session? Okay. Thank you very much, everyone. And thanks to Andrew, Jenny, Juan. Niels was also there for a short while, I guess. Thanks for the wonderful presentation, and it was a wonderful workshop, I guess. Thanks for all your help and support, and also would like to thank AWS for arranging this workshop, as well as sponsoring some of the prizes. Thank you so much, and we look forward to have these workshops in a large scale on campus very soon.
Thanks, Nabin, for having us.
Thank you so much. It's a pleasure.
Thanks a lot. Cheers.
Thank you, everyone, and have a wonderful day. And keep an eye on the website for the new date for the showcase, which will be potentially on campus. looking forward to it, everyone. Thank you. Have a nice day.
Thanks, everybody.
Joanne, before
Yes.
we conclude the session, are we allowed to share the slides?
Yeah, I don't see why. So do you want me to send you a PDF of the slides? Why not?
Yeah, that will be wonderful. So because this recording will be there, and we intend to have this a good version of this recorded session on the website. If possible, if we can get the PDF, that would be wonderful as well.
Okay, definitely. So yep, I'll take care of that.
Thank you so much. Thank you. Have a wonderful day, everyone, and looking forward to see you on the showcase day. Thank you. Bye-bye.
Thank you.
Thank you. Bye.